So just I'm sharing the screen. Okay. Can you see the screen?
I can, sir.
Yeah. So see now, just two more points. So the D part they're asking, using your answers in A and C third. A is what? A is this. Huh?
Mhm.
Okay. Expression for the gradient. And C third. C third was what? This. Huh? Gradient of best fit line and its uncertainty. Okay.
Mhm.
So using this, what we have to do? We have to find out, determine value of S. S I have to find out. Okay. And include an appropriate unit. Okay. The value of capital D is given, that is the screen distance is given to you.
So D divided by the gradient that we just found out, and D is like 2.2. So that will be divided by the last like gradient of the last answer, right, sir?
Yeah. So see here how we will find out. Hai na? So yeah,
Mhm.
D by S is the gradient. Hai na? So S will be
Yeah.
D by the capital D by the gradient. Okay.
Mhm.
Capital D by the gradient it will be. So gradient whatever you have found out for the best fit line, use that and you just divide it. Okay, and give some 2-3 significant figures. Okay.
The answer would be in millimeters, right, sir?
Yeah. Yeah. Okay. Yeah.
Okay.
So see, it is for 3 marks. Hai na? So do it properly. Okay. Show the steps. Okay. Write down this formula like this. Okay. Show the steps. Okay. 2-3 significant figures you give. Okay. Also, yeah. Okay. And then next they are asking is what? Find out the percentage uncertainty in S. Hai na? So uncertainty in S
Mhm.
also you have to find out. So how will you find it out?
But I mean, the first line, like we can the first gradient that we found out upon the second gradient into 100%, and I think like we
So,
already found out the percentage uncertainty of D.
uh,
So, and then we can add both of them together.
see, like this we will find out. Okay. So what is the expression that we are getting? We are getting S is equal to D by gradient. Hai na? S is equal
Mhm.
to D by gradient. So see here. S is equal to D by the gradient. है ना? D by the gradient. So the error in percentage uncertainty, how we find out? We find out something like this. है ना? Delta S by
Yeah.
S, है ना? We have to take
Yeah.
and multiplied by 100. So get it in percentage. है ना? So that will be equal to delta D by D. Okay. Multiplied by 100 plus it will be delta, that is uncertainty in the gradient. Okay. Upon uncertain upon the gradient. All right. Multiplied by
Yeah.
100. So see, uncertainty in the gradient we have already found out. है ना?
Mhm.
By finding out the slope of the best fit and the worst fit and subtracting them. Gradient we will
Yeah.
know for the best fit. D is given to you. This
Mhm.
is given. This is given here.
So 0.02 upon 2.20
So
into 100.
capital D will take 2.02 and this plus minus
Yeah.
0.02. This is the delta D. है ना? Error.
Yeah.
है ना? So that we will do and we will put it and we will solve it. Okay, and we will get the answer. Okay. Like this,
0.9%.
like this we will do. Okay.
Yeah.
This we will do. And then see, there is the last part of the question. What is given? The experiment is repeated using the same double experiment, but okay, so same double experiment we are using, that means same value of an S we will take, okay, capital D we will take, okay,
Mhm.
but an unknown wavelength. Now the wavelength is not given to us, okay, and distance between the fringes that is given to us as 35 plus minus 0.5 m, okay. So
Mhm.
again, what we can do, we can divide it by 10 and we can find out value of the P. Okay. So now we
Yeah.
have to find out the determine lambda and absolute uncertainty also we have to find out. है ना? So how we can find it out? We will
Mm,
use that relation again. Okay.
T is equal to ds upon lambda into
Ah.
lambda.
So the relation is given to that was relation was what?
T is equal to d by s into lambda.
P, this P is equal to है ना?
D by s into lambda. So d by s is like our gradient, right, sir?
Okay. So
Mhm.
this is the gradient है ना, which we have found out.
And
So
p
lambda,
can be w by 10.
so it will be P divided by the gradient. Okay.
Okay.
P divided by the gradient. So P we can find it out, gradient we already know, you just divide it and you will get the lambda. And then uncertainty also you have to find out. So that is delta lambda by lambda will be what? Equal to
Mhm.
delta P by P. Okay.
And yeah, delta of the gradient, delta of p into 100.
P, and as error gets added up, so it will be plus.
Mhm.
Error in the gradient, delta gradient upon gradient. Okay. So here absolute
Mhm.
uncertainty they are asking, not percentage. Okay. So you find out the right hand side and then delta lambda will be equal to what? Whatever value you get. Okay. That means this value.
Mm.
You have to
Okay.
multiply that with the lambda. So that will be the absolute uncertainty. All right. Okay. So
Got
see,
it.
like that they have done here. Okay. So they have found out the lambda as that value of P divided by the gradient. Okay. And then uncertainty as that
Mhm.
delta P by P plus delta gradient by gradient into lambda. Okay. So you will get it like this. Okay. That is the easier way. Okay. So you have found out the wavelength also and the its uncertainty and absolute uncertainty also you have found out. Okay. So that is the end of the
Got it.
question also. Okay. So I will send you this past paper and maybe some more papers also. I
Yeah.
will do. You practice in this.
Thank you, sir.
If you have any doubts, you can get back to me.
I'll ask you. Thank you so much.
And read this and this last part, last 30, 20, 30 pages, okay, of this book.
Mhm.
Okay. This is just
Got
of the paper 5, related to the paper 5, toward the end of the book. Okay. So here
Got
all
it.
these things they have mentioned, how to find out the error and all. Okay. All these things are given
Mhm.
to you. Okay. Now
Got it.
one more thing. Okay. Sometimes they give you in the log. Okay. Sometimes
Mhm.
they give you this table. Okay. This table is like in the form of the log. Yeah, like they will give you in the log of lambda and a log of w and a log of p. Okay. So in that
Mhm.
case also you have to find out the absolute uncertainty. So how you can find out the absolute uncertainty for the log, that is little different. Like here, see this resistance is given as 47 plus minus 5. Okay. So
Mhm.
this plus minus 5 is the error. Now you have to find out the error in the ln of r, ln of the resistance. So how you find out the error in this? So first you find out ln of 47. Okay. Then you find out
Mhm.
ln of 47 plus 5. Okay.
Okay.
And then you subtract it. So when you subtract it, you get the error. Okay. So to find out the error,
Understood.
it is different. Okay. In this. Okay. For the ln. Okay. So you see these kind of different cases. Okay. And also something, suppose. So read something on errors. Okay. Error analysis. Okay. That will be
Understood.
helpful. Okay. It will be helpful. Okay. So. So like I have shown you in this case, I have shown you, okay, that y equal to ax to the power n. Okay, so that is ln f,
Mhm.
y equal to ln a plus n into ln x. Okay, so they can tell you find out the error in this. Okay, so how you find out error in this? You can divide it. Okay, you can,
Mhm.
first of all, you will do like this only. Okay, and then what you can do is that you can divide it like this. Okay, so it will be something like this. Okay,
Mhm.
so it will be delta y by y. Okay, upon y. Okay, that is equal to delta a by a. Getting the thing? So like this, we find out the error. Okay, plus
Okay.
n times of delta x by x. Okay, so like this, we can find out the error. Okay, and then
Mhm.
sometimes the error is like this. Like suppose it is same quantities are given. Like you are measuring say time period t1, time period t2, and then say say you are finding out the average, that is time t, that is equal to say t1 plus t2 by 2. Okay, t1 plus t2 by 2. Okay,
Mhm.
so in that case, suppose they ask you the error. So suppose error in say time 1 is given as say plus minus 0.1 second. Error in T2 is say plus minus 0.1 second. So then what will be the error in this T? So what happens? Error gets added up, and whether we are adding the quantities, subtracting the quantities, okay, multiplying or dividing, error gets added up. Okay, so here the error will be now plus minus 0.2 seconds. Okay, so we do like this. Okay,
Mhm.
if it is say t to the power 4, so error will be 4 times the error in the measurement of t1, something like this. Okay, if it is to the
Okay.
power, it becomes that power multiplied by that error. Okay,
Mhm.
so these are some of the points for error analysis. Read that these things are given in this chapter and toward the end of this, okay, the book, and solve some more past papers. Okay, write it down. Okay, better write it down so you can practice it.
I'll write it, sir.
So you will get a better practice for that. Okay, so that's it for today's
Understood.
class. I'm ending this meeting. Okay,
Thank you so much, sir. Have a good day.
yeah, take care. Huh? Bye.